straightforward manner. So you have you can both of them. So you have two sine and cosine. They both you you get your answer differently in both cases. Okay. See, see if there's okay. So you just follow the recipe. So now this d theta is I minus I dc over g, and cosine is 1/2 c. That's one of this. And then you know the integrate over a unit circle. Right. All right. That's it. Right. The rest is just the calculation. That doesn't matter where we are. AG plus minus b over 2 b squared plus that's 1. Right. It's easier to put all these factor out first. So minus I minus b over 2 c squared. Now it's plus or minus becomes minus plus minus because you want a back. Right. Now you figure out the zero in the denominator, which is z plus the minus. Oh, yeah, you're right. T over b. Right. All right. Plus the minus is the 0 or holes in the integral. As 1/2 of minus b, right? So minus 2a b. Now you got 2. You got 2 plus or minus. All right. So either case you have plus or minus. Okay. So yeah, alternate. This is not related, right? And now it's b squared minus 4. Right. And you have a plus or minus out, but still you still have a plus or minus inside because they are not related. That might turn out to be same. I mean, doesn't matter. Now whether you write it plus negative or positive doesn't matter. So, A, B, that's a minus b squared. Okay. That's 5 and Now there's a condition A is greater than B. A is let's actually take that out -1. A is greater than B, so this is greater than 1. So it's real inside. I mean, it's positive inside, so it's real. The two zeros are real, or the two poles are real, right? And you can figure out that both A and B are positive. Assume they're positive, or what doesn't matter?
That's correct.
Oh, yeah, because you have plus or minus sign, that doesn't even matter, right? So in a circle. So this is a number that is greater than 1, magnitude greater than 1, either here or there. So A over B is here. So consider one case. So if A over B is here, right? Then you have plus and minus something that is also real. And I suppose one would be inside, one would be outside. Can you see that one is outside, the other is inside? How do you see it? That must be.
Yeah, slightly. It's
Right.
left and right to right.
So obviously, if A and B are positive, you add positive. One is over here, that is outside of this semicircle. The other is you minus something. So minus something -1. So you want to see whether A and B minus square root of A and B square -1 is less than 1. You want to see whether it's less than 1, or A over B is less than square root of B. B square. That doesn't work. It's
1 plus root of S square.
This is plus.
No, when you take it to the other side of the equation,
Oh yeah,
it would be 1.
1. Yeah. 1 plus 1. Yeah. Right. So this is greater. This is greater than 1, but you are 1. And this means whether A over B square is less than the square of that, which is A over B square -1 plus 1 plus 2 over B square. Is that true? 1 and 1 cancel. This cancel. Whether this is greater than 0. This is greater than 0. Right. Okay. It take a while to actually see that. I mean, I cannot see that right away. Okay, one is outside, one is inside. So there's only one pole. So you can call it C plus, this is C minus. And this is for the case A over B is greater than and positive. If it's negative, then it's still plus and minus. Then C minus will be outside the unit circle. A plus, Z plus will be inside, right? So inside if whatever that is, this is negative number plus the plus sign will be inside, right? And for this case, the plus sign will also have the minus sign will be inside. Okay, so it depends on the situation whether A and B are positive or negative. But anyway, that might have enough information. Therefore, minus plus 2R would be minus C. How about we just do one sign for A over B first, and then see if this is just to give it is that would actually be the answer of the textbook. Okay, so now continue. This means it's equals to, this is a simple pole, and you have a pole C minus, so you multiply C minus C minus. I cancel that and then evaluate C minus minus C plus, right? That equals to minus 2. I mean, I think what should we use this minus plus? Well, we probably could figure out that by the sign of the integral later. So let's figure that out later. But calculate the recipe first. 2 pi I times C minus C plus. Right? And C minus minus C plus is this minus that. There's a plus or minus. So the first term will cancel. The second term will give you two of them. And that will give you a plus, another plus or minus sign. Give you a plus or minus times 2. Plus 2 pi I times I minus 1, 4 pi b. And that gives you a plus or minus 2 times in the b squared. Right? But there's no this. I mean, this I didn't write. This is good. Okay, so looks like this sign cancel with a negative sign, so it's just 4 pi. That becomes 2 pi c squared. That goes way too low. Get my answer. Right. And the textbook answer, you multiply b inside, become a squared minus b squared. That's fine. I got the textbook answer. Right. Which step do you not get? So you're saying you get an extra factor.
We had extra. Yeah.
But which part will give you the extra factor? I mean, I went through. I get the textbook answer. But at least for the first part, this cosine, the sign should be straightforward to show that the two integrals are actually the same. Using the I. Yes.
Yeah, it has to be there. Yeah, we just swap the I.
What is I?
I think we take the divide by 2a by b. Yeah, I don't need it. Yeah, we forgot that.
You forgot that. Okay, so just you identify where you went wrong. That's fine. So I make that mistake. Okay. So not too bad. As long as we're careful. All right, the sign I will have with you. I mean, you can either do it again or there's identity that like this is periodic function, right? So like you shift it by a little bit, and the cosine become cosine.
Just the b by 2 out without the plus and minus. When you take the b by 2 out, the next not down.
Yeah.
When
you need that because there's a plus and minus. You take,
yeah, so we can just keep it inside the plus and minus. Just keep it inside itself.
But then the formula goes with the plus and minus because you divide the formula called for divided by the coefficient of the c squared term. Right? 1/2 the coefficient of the square term, right? That's you remember the quadratic formula, right? 1/2a and minus b plus and minus, right? Yeah. You know, the formula has you need to divide it. If you leave a coefficient in the c square term, then you need to divide it.
Just take the b by 2 without taking the plus and minus out.
And then you still need the plus. The coefficient is still either plus or minus.
So there won't be a plus or minus outside.
But I mean, the final answer should be the same.
Yeah. Okay.
Well, you can do that, and obviously, any way you do it, can get the final answer is fine, but you still get the same answer. Okay. And I was just saying that the second equation with the sign term, another way to do it is shift domain because it's periodic function. You are always shift it up and down the plus or minus pi or 2 pi or whatever convenient, and change the sine function to a cosine function to get exactly the same integral. Either this or just going through again using sine.
So when we change the domain, should we change the integration limit? So if we change it to
this limit is fine. This limit, whatever you can say you are not integrate pi minus, you can not 0 to the pi minus pi to pi is still the same. Finally, you just integrate over a loop of unit circle. Whatever the limit, as long as it covers 2 pi, is fine, right? You still get exactly the same loop integral. Okay.